Hi everyone, so I am helping some year 12s out for maths, and so I thought why not just film the video and share on YouTube just in case someone else might find it useful. So it's a long one, but it took me probably 10 times as long to do this, so I hope that it helps in any way, and if it does, please like and subscribe. And I'm just a year 13, so it might not be as good as a teacher, just saying, but if it helps at all, then I am proud that I did this, so enjoy. So basically, hypothesis testing is just testing whether the probability found in a situation is due to chance, or is it actually because of is it actually accurate. So if it is due to chance, that by chance I went to buy ice cream when it was sunny and not because it was sunny, if that's just a coincidence, then it's not valid, it's not reliable, and so it's not good enough to say that it's actually true, and therefore we will reject the result. So yeah, if basically the whole hypothesis testing is just about checking whether the situation, the results found in a situation is because of chance, or if it's because of actual significance. There's an actual relationship between the two factors. So if you have a hypothesis, then that means you have to have hypothesis. So you have two types of hypothesis. No, wait. 3 types. Yeah. So H0 is the null hypothesis. H1 is the alternative hypothesis. And for the alternative hypothesis, you basically have one direction, one-tailed, or no direction, two-tailed. So the null hypothesis is the hypothesis that we always assume to be true in the question. So yeah, you always have to assume that it's true, and basically in the question they would normally tell you the situation, and it's really straightforward, and they would just tell you directly that, for example, the probability of presents having ice cream when it's 20 degrees outside is 55%, and they would just tell you directly, and it's a null hypothesis, and you assume it's true because it's the figure that you basically want to test. It's the figure that you want to prove that is true, it's accurate and not because of chance, but then you might find a contradiction and you reject it. The probability that we want to test or prove So it's the probability that we want to prove true, and therefore we always assume that it's true in the question, and if we find out that the assumption is wrong, then we know that the null hypothesis is wrong and we have to reject it. So for the alternative hypothesis is basically what is the result if this one is wrong. So what would the alternative hypothesis be if the null hypothesis was wrong? And they will always say it in the question. So they will always tell you in the question. Okay, so yeah, they will always tell you the alternative hypothesis in the question. And how would they do this? So, let's do this. So basically, when the question says that, let me find an example actually. So it can vary. They can be like either more vague or they can be more direct. So basically, they think the probability improved or increased, anything of that sort, then that would mean H1P is bigger than the, I guess, X, let's say, the null hypothesis, which is basically, no, that's not a good way to see it. So, like, H0P equals X, then H1P would be bigger than X. And then if they think that P is maybe like worsened, you know, reduced, anything of that sort, then H1P is going to be less than X. Or they might say they think that P has changed. And changed just means that it's a non-directional hypothesis, so P does not equal to X. And that is basically what to choose when, you know, you have to think of a different, like you have to think of which alternative hypothesis to use.
So, example. An example is from the Edexcel textbook. Okay, so basically, exercise 7A, question 6. We're going to go for the hardest question. Okay, so the first question is that the test statistic. And then the second question is
Zoom in, and I'm gonna put some nice music on around like 1 minute, and then You can pause it if 1 minute is not enough, and then I'll go through it. So the test statistic is just the statistic that you use in the hypothesis test. So in this case, it would be the number, the number of the number of people, the number of supporters. The number of supporters found in a sample. Of 20. And then the suitable hypothesis, so remember you have H0 and you have H1. Now, because H0 is 50%, so 55%, sorry, oops. So they already told you clearly that 55% support this yellow guy. And so it is easy. So basically, so the probability equals 0.55. You always write it as a decimal. And H0, well, that is also easy because, you know, test at the 2% level, blah, blah, blah. Whether the level of support reduced. So yeah, so basically it clearly says reduced, so it would be P is less than 0.55. Part C, explain the condition explain like when H0 would be accepted. Okay, so the question asks you about being accepted, and yeah. Or should I use a different colour? Let's use this one, and let's just trim this one. Okay, so explain if the condition is be accepted. For this question, you know that the significance level is 2%. And what this means is that if the probability of the number being 7 is more than 2%, this means that this didn't occur by chance, which means the null hypothesis is accepted. So that was the first part of hypothesis testing, so the intro, and next part is about finding critical values. Okay, so now let's move on to critical values. So basically critical values are just the first values that are in the critical region. And a critical region is a region, so the definition says that it's a region of the probability distribution which, if the test statistic falls within it, would cause you to reject the null hypothesis. That actually, anyway, in my words, it basically means it's a region where if you find that the probability falls within the region, then it means that the results you found are due to chance and the results are not reliable or valid, and so you can't rely on the null hypothesis that you assumed true at the beginning and you reject it. So let me just write, what colour did I use? Used yellow. Okay, so a critical region.
So the region where if the probability falls within it, it means the results is due to chance, and it's not accurate or reliable or valid. I don't know which one to use, which means you reject H0. Does that look okay? Yeah. So you reject H0. And the critical value is
So how you find the critical regions and critical values, you basically only need to use your binomial table or your calculator, which we will touch upon later. We also have the actual significance level. I will explain more about the actual significance level when we come to an example, but what it is basically the value that you find in the question instead, and use that instead of using what they tell you the significance value is, which is normally 5%, 1%, 10%, but what you will find is a very specific number, and you either use that or you have to add it together if it's a non-directional hypothesis, and I will explain more when we get to the example. The actual significance level of a hypothesis test is the probability So the book definition is the probability of incorrectly rejecting the null hypothesis. Now, I'll be honest and say that I didn't really pay attention to this definition, but I guess in case they ask you to define it, you should remember this one. In my brain, I just remember that it's the number that I find using my calculator or the table, and I just either use that or I add it up if it's a non-directional hypothesis. But I'm sure that if you want a specific explanation, a teacher would be better to explain this than a year 13 random person. So let's find an example. Actually, before, one thing that you guys should know is that the critical region is different depending on which hypothesis type you use. So basically we go back to hypothesis type. So one direction, you use the significance level in the question, and for
actually not one there, let's use it tailed. So for one tailed, and then for two tailed, so for two tailed,
you have to basically divide the significance level in the question by 2. Well, so, question 7b from the textbook. A mechanical component fails 3 times on average out of every 10. An engineer designs a new system of manufacture that he believes reduces the likelihood of failure. He tests a sample of 20 components made using a new system. And I skipped question A and B because it's from the previous section. So basically the question is, using 5% significance level, find the critical region for a test to check his belief. And the next question is, find the actual significance level of the test. I will put some music on and let you try it. Oops, that's bad news. And one minute, and 1 minute. Okay, so let's look and see if there's any special things in the question that we can kind of circle out. So 3 times out of 10. So that you can kind of see is the probability. So the probability of the component failing, which is the null hypothesis. It's normally at the very start of the question, very straightforward. And then the engineer designs a new system. He believes that it will reduce the likelihood. Okay, so reduce probability of failure. And then he tests a sample of 20. So that is the value of n in the binomial distribution. And the question asks you to find at the 5% significance level the critical region for the test. Okay, so here I will put the steps. So step 1,
find H0 and H1. Or that might be step 2 actually.
Step 1 is, I think, you have to kind of write the binomial distribution. Step 2 is you find the hypothesis test, no, not hypothesis test, H1 and H0, and then 3 you find the region. So step 1 is that you have to let x be the random variable so let x be the
number of components that fail, and x is the binomial 20, and then p is the probability, and then 2, you know that H0 is from here, so 3 over 10, well, basically 0.3.
And because you assume H0 always, you assume that H0 is true. Then x is b 20 0.3. And step 3, you find the critical region. So the probability of x is less than, let's call this a, it has to be less than 5%, 0.05. The probability that x is, because this is a one-tailed test, right, let me just write this down. So because this question is a one-tailed test, so the critical region is going to be either the probability of x is less than a certain number will be less than 0.05 or 5%, or px is bigger than a is less than 0.05. It's always going to be less than 0.05. And if it's a two-tailed test, then you would have to do the same but include both p is less than a and p is bigger than b, because two-tailed means it's in both directions, and you have to, they won't tell you this, so you need to remember that when they tell you to use 5% significance level, you need to divide 5% by 2, so it will be less than 0.025. Yeah. Now, to do this part, you can use tables, which is in formula booklet, or use the calculator. The table might be easier, but I tend to normally use the calculator. So basically you can use a calculator to try out a few different numbers and see which matches or is closest to 0.05, or use the tables. So what you will find is that px is less than or equal to 2 equals 0.0355, and the probability x is less than or equal to 3 equals 0.1071. So which one do you choose? Well, so you need to find the value that is less than 5%, and we know that this is less than 5%. Therefore, that's the answer. So we can say that the critical region is x is less than or equal to 2. So for hypothesis testing, it will always be in the form of like p is brackets x less than that. Like, that just means like the probability of x is less than a certain number is less than the significance level. So just remember that it's always like the arrow is always less than. I mean, I always made the mistake, so just in case I'm not the only one, I might just say it. So basically, for part B, all you need to do is just this. It's just this. You put it there. That's all you need to do. And that is how you find critical values and critical regions.